Question 22 here. We are being asked to put a fence in, and we get to use a house along one side, so we only need the fencing on three sides. What I like to do with these is, what are the questions? Find a function that gives the area of the garden, length times width, so we'll get there. What side length x gives the maximum area, and what is the maximum area? So what we're going to see, now let's just go ahead and do this. So we've got a side x there, so that means x over on this side. Again, we're not going to use up any of the fence here. So then what is this side? Well, we could just call it y, but watch, we know that the perimeter is going to be a total of 160 meters. We've got two sides which are x, whatever that is, so that's a 2x. So those are those sides. And then when we add y to it, that's the third side, we're going to end up with 160. So what we can do is we can figure out what y is in terms of x simply by subtracting 2x from both sides. It's going to give us that side y is actually 160 minus the 2x. So, and that makes sense. We use x and x here. Whatever's left over is 160 minus that. So we're going to put that as 160 minus 2x. Okay, so that's our setup. Now, how about area? Area is length times width with a rectangle. And we've got our length down here. That's our y value, 160 minus 2x, times x. So we can say easily that our area, a of x, is going to be 160 minus 2x times x. And of course, we'll distribute this through, so we end up with 160x minus 2x squared. So we see we have a quadratic, and we go ahead and enter that in. That's going to give us our area. And again, we're using x, so just make sure you're using the right variables. So now, how do we get the maximum area? Again, much like the last question, since it's quadratic, it opens as it looks like the graph looks like a U. Either, let's go with this one. It'll be a U this way or this way. Since we've got a negative in front of the x squared, it's going to look this way, so we're going to have a maximum right here. So not this one, we're going to get a maximum. The thing to be careful about here is we're going to use the same formula to find the vertex, but this time, at least the way we've got this set up, this is bx plus, ax squared. C is going to be 0, because there is no c, but plus 0, so if we needed c in some formula. But our formula for the vertex is that vertex, the x-coordinate of the vertex, is minus b over 2a. That's going to give us the answer for b. To get the answer to c, we're going to plug that into the function we have here to actually calculate the area. Okay. So what is negative b? So negative b is 160. It's positive. 2 times a is actually negative 2, so we get that. So it's going to be negative 160 over negative 4. 4 goes into 16 4 times with a 0, so we end up with 40. So the length of the side x should be 40 to get the maximum area. And then whatever's left over will be the y, right? And again, if you wanted to, you say, okay, that's 40. Let's plug in 40 here. That gives us 80. 160 minus 80. That's going to give us 80 as well, right? 160 minus 80. Or we can plug it in up here. Either way, now take 40 times 80 and you'll have your maximum area. But again, I'll show you what we do is we define the y coordinate of the vertex. We get that y equals 160 times 40 minus 2 times 40 squared. So that will be our total area. It's going to be done. So let's go ahead and bust out the calculator, move it over a little bit. So 160 times 40 minus 2 times 40 squared. So it kind of figures it all out for us. 3,200 square meters. We'll go ahead and just put that in, 3,200. 3,200. And up here, we don't want to forget this, 40 meters. And again, you could do a check, is 80 times 40, is that 3,200? Well, yeah, 8 times 4 is 32. With the 2 zeros, that should be 3,200, right? So it's kind of good to check things two different ways if you can. Anyway, using the vertex to come up with the area. Thanks.